So good morning, everyone, or good day, everyone. In this video, we will have a quick overview about what recurrence relations are. So a recurrence relation for a certain sequence A sub n is an equation that expresses A sub n in terms of one or more of the previous terms of the sequence, namely the A sub 0, A sub 1, A sub n minus 1, for all integers n with n greater than or equal n sub 0, where n sub 0 is a non-negative integer. So we can say that a sequence is called a solution of a recurrence relation if its terms satisfy the recurrence relation. So here's an example. Suppose we have a sequence A sub n that satisfies the recurrence relation A sub n equals A sub n minus 1 plus 3. So as you can see, this A sub n is expressed with its previous terms n minus 1. Okay, so this n is greater than or equal this n minus 1, right? So n minus 1 is a previous term followed by the next term, n. So for n equals 1, 2, 3, so and so on. And suppose the value of a sub 0 is 2. So what would be the value of a sub 1, a sub 2, and a sub 3? So this would be the solution. So we have the a sub 1, and that is the n is equal to 1. So a sub n minus 1, that would mean that subtracting 1 to n, so that means a sub 0, the previous term a sub 0. So this a sub 1 is expressed with its previous term a sub 0 plus 3. Okay, and we know that a sub 0 is 2, so we have 2 plus 3 equals 5. So now, what would be the value of a sub 2? So if n is equal to 2, that means that a sub n minus 1 would be the a sub 1. And we know that a sub 1 is equal to 5. So we have 5 plus 3 equals 8. And what about for a sub 3? And we know that the a sub, if we have the term a sub 3, the n would be 3. And if n is 3, then n minus 1 would be 2. And we refer to the term a sub 2. So a sub 2 is equal to 8. So we have 8 plus 3. All right. So let's have another example. So suppose we have a sequence a sub n that satisfies the recurrence relation a sub n equals a sub n minus 1 minus a sub n minus 2 for n equals 2, 3, 4, and so on. Suppose that the value of a sub 0 is 3 and the value of a sub 1 is 5. So what are the values of a sub 2 and a sub 3? So this is considered as a recurrence relation because the a sub n is expressed with its previous terms for two previous terms, a sub n minus 1 and a sub n minus 2. Okay, so what would be the values of a sub 2 and a sub 3 given a sub 0 and a sub 1? Okay, so we have the a sub 2, and if we have a sub 2, that means n is equal to 2, and the that means a sub n minus 1 is a sub 1, and a sub n minus 2 is a sub 0. Okay, so we know that a sub 1 and a sub 0 are 3 and 5 respectively. So we have a sub 2 equals 2. Now, the a sub 3, that means that n is equal to 3. So that means that a sub n minus 1 is equal to a sub 2, and a sub n minus 2 is equal to a sub 1. And the a sub 2 is the result of the computation that we've had earlier, which is equal to 2. So it's now going to be used in this term. And the a sub 1 is a given a value of 5. So we have 2 minus 5 equals negative 3. Okay, so another example of a recurrence relation is a Fibonacci sequence. F sub 0, F sub 1, F sub 2, and so on. So in the Fibonacci sequence, assuming we have the initial condition 0 and 1, so F sub 0 is equal to 0 and F sub 1 is equal to 1. So a Fibonacci sequence is expressed in this equation. We have F sub n equals the sum of its two previous terms, f of n sub 1 and f of n sub 2. So let us try to find f sub 2, f sub 3, f sub 4, f sub 5, and f sub 6. So this would be the solution. So for the f sub 2, so the f sub 2 is the sum of its previous two terms, f sub 1 and f sub 0. So the f sub 1 and f sub 0 are 1 and 0. So f sub 2 is equal to 1. So now our sequence will be 0, 1, 1. Now the f sub 3 would be expressed with its two previous terms, f sub 2 and f sub 1. And we have computed f sub 2 previously, which is equal to 1. And the given initial condition, f sub 1 is equal to 1. So f sub 3 is equal to 2. Now, f sub 4 will be computed with its two previous terms, f sub 3 and f sub 2. And f sub 3 is equal to 2, right? We have computed this earlier. And f sub 2 is 1. Okay, so we now have the result of f sub 4 is 3. Now we have, you just continue computing this. Okay, so we have a form the sequence 0, 1, 1, 2, 3, 5, and 8. I think this is familiar to you, Fibonacci sequence, right? Okay. So you can picture it out like this in okay, so we have 1, 0, 1, 1, 2, 3, 5, 8, and 13. And you can also use the concept of Fibonacci in some other problems like reproducing rabbits. Okay,